Okay, so this is the 2023 Higher Level Maths Leaving Cert Paper 1, question 9. So let's see, we have Ava and she is investigating factors of different numbers. First she looks at numbers that can be written as powers of a prime number. So list the 5 different factors of 2 to the power of 4. You can write each one as a power of 2. Okay, so the first factor then that we can look at is 1, and that can be written as 2 to the power of 0. Next one would be 2 to the power of 1, and then you've got 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. So that's it really. Let's see, list the 5 factors, and we've done that, and we've written each one as a power of 2. Okay, second one I think is something similar. Work out how many different factors 3 to the power of 7 has. Well, 3 to the power of 7 would have 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of 5, 3 to the power of 6, and 3 to the power of 7. So the answer is 8. So one more than the power, in other words. Work out how many different factors 2 to the power of 10 times 3 to the power of 12 has. Well, 2 to the power of 10 has 11 factors. 3 to the power of 12 has 13 factors. And basically this is a question, I suppose, based on the fundamental principle of counting. So we've got to multiply these two. And our answer there is 143. And that's basically it. Next one, I've kind of done this one, but let's see. Ava also looks at the relationship between pairs of factors of a number. She makes a table to show pairs of factors of 12. That is, the pairs of natural numbers x and y, so that x times y gives you 12. Complete the table below. So I've done that. 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, 12 times 1. It then says plot the 6 points above on the coordinate diagram below. One of the points is shown. So again, I've done that already. And you get this. I haven't joined them up, but it just says plotted, so that's all I've done. The next question then says Ava realizes that the relationship between x and y is y is equal to 12 over x. On the coordinate diagram above, draw the graph of y is equal to 12 over x in the domain 1 to 12. Okay, so I think really all they want you to do here is join these dots up. It's kind of a strange question. I'm not sure why they didn't combine this in the one question, but anyway, we'll just join them up. So it's the curve anyway. I've just missed that one there, but you get the idea. So it should look something like that. Now, I'm not sure if they want you to draw a table here as well, but I mean, really that's the table up there. This is it here. I mean, you could go through the procedure of writing down the x, 1, 2, 3, 4, 6, 12, but you're really just doing the same thing again. The function is 12 over x. Write down y and the points. 12 over x, 12 over 1 is 12, so the point is 1, 12. Second one here is 12 over 2, so that gives you 6. So that's 2, 6, and so on. Look, I'm not going to finish that off, but I think that's all they want you to do there. So fairly easy marks there if that's all that's required. So let's have a look. A tangent to the curve y is equal to 12 over x is drawn at a point P, 12 over P, where P is real and P is positive. Show that the equation of this tangent is y is equal to minus 12 over P squared x plus 24 over P. Okay, so this is just the equation of a straight line. And you know that the equation of a straight line is y minus y1 is equal to m into x minus x1. So we need two things to go into this formula here. We need a point, and we have a point up here, P. So we have our point P and 12 over P here. So this really is our x1, y1 if you like. And then we need the slope as well. So the slope we have to find. Now the slope, we know our function is y is equal to 12 over x. And that's just x to the power of minus 1. So this is our function, this is this function here. So we want to find the slope, so we've got to differentiate this, dy dx. So bring down the minus 1, so that gives minus 12, x to the power of minus 2, reduce the power by 1. So really that's just minus 12 over x squared. Okay, so what we've got to do next then is just find the slope of the tangent at this particular point here. So at this point here, we know that x is p. So in other words, the slope of our tangent is minus 12 over p squared. Because remember our point, the tangent touches the curve at the point where x is p. So now let's just stick all that information into our equation of a straight line here. So it's going to be y minus y1. Well, y1 is 12 over p is equal to m, which is the slope, minus 12 over p squared, times x minus x1. Well, x1 is just p. So this is our answer here really, but we've got to put it in this format here. So let's just mess around with it. So let's see, we've got y minus 12 over p is equal to minus 12 over p squared times x plus, minus minus is plus, let's see, we've got 12 over p. Because you've got a p squared on the bottom, you've got a p on the top, so that will cancel with one of these p's, so we're just left with p here. So we've got to get the y on its own then, so it's going to be y is equal to, now we want the minus 12 over p squared first, so minus 12 over p squared is going to be first. Now we've got to add 12 over p. So we've got a 12 over p plus another 12 over p, so that's plus 24 over p, and that's it there. That's it done. Okay, so that's it for C part 1. Let's have a look at C part 2. The area of the triangle formed by the x-axis, the y-axis, and the tangent that we've just worked out the equation of is always k unit squared, where k is natural and it is a constant. Work out the value of k. Okay, so basically we've got the area of a triangle here. Now there are loads of different ways of working out the areas of triangles, but the very first one that you've learned is half the base times the height. And this is a right angle triangle here because we've got the y and the x-axis. So this will be our base here and this will be the height of our triangle. So that's what I'm going to use. So we need this distance here and we need this distance here. So I need to know what this point here is. In other words, where this line cuts the x-axis. So at y is equal to 0, at y is equal to 0, that will be this point here. So remember, this point here will have coordinates something 0. This point here will have coordinates 0 something. So if I can work out this something here and this something here, I'll have the base, I'll have the height, so then I've just got to use half the base times the height. Okay, so let's do this. Y is equal to 0. So we've got our formula here, 0 is equal to, that's this y here is 0, is equal to minus 12 over p squared plus 24 over p. So let's just, that should be an x here as well. So we've got to work out what x is. So bring this over, you get minus 24 over p is equal to minus 12 over p squared x. That'll give me, let's see, what can I do here? Well, let's just get rid of that first. P is equal to 12 over p squared x. Now what I can do here is multiply across by p squared. So if I multiply this by p squared, I'll end up with 24p. If I multiply this by p squared, I'll end up with 12x. So that'll finally give me x is equal to 12 into 24, which is 2p. So my x value is 2p, so that's going to be here, 2p. So I know my base now. So now let's work out the height of the triangle. So to do that, we need x is equal to 0. So we want x equal to 0. So let's do that. So our formula is y is equal to minus 12 over p squared x plus 24 over p. So we want x to be 0, so put 0 in here. That'll get rid of all of this here. We just end up with y is equal to 24 over p. So this value here, the height of our triangle, is 24 over p. Okay, so let's just put that into our equation for the area of a triangle. So the area of a triangle is half the base times the height. So our base is this value here, 2p. So it's half of 2p times the height, which is 24 over p. So 24 over p. So this is handy because we were asked to find the value of k, and we had this extra variable p in here, so that's now going to disappear, which is handy. So our answer here is just 24 units squared. So that p will cancel with that p there. We got half of 2, which is 1. 1 times 24 is 24. That's it for this question.